When a process requires a rapid control action that eliminates offset, a control mode known as proportional plus reset plus rate control may be used. It combines the precise response action of reset control with the fast response action of rate control. Proportional plus reset plus rate control is sometimes called PID control. P for proportional, I for integral, which is the same as reset, and D for derivative, which is the same as rate. One example of a process that requires PID control is the gas-fired oil heating furnace represented here. During operation, oil flows through a pipe in the furnace combustion chamber. Gas flows through a valve in another pipe to a burner. As the gas burns, part of the heat that's produced is transferred through the pipe to the oil. The controlled variable is the temperature of the oil leaving the furnace. A sensing device in the oil pipe provides oil temperature readings to a temperature transmitter. The transmitter measures the temperature and provides a corresponding pneumatic signal to a controller. The controller uses that information to produce an output signal, which adjusts the control valve to regulate the furnace flame. Since the flow of oil through the pipe is reduced, there's more time for the oil to absorb heat and its temperature increases. The control system responds by sending a larger signal to close down the control valve. This reduces the gas flow to the burner and decreases the amount of flame. As a result, less heat is transferred to the oil, and the oil temperature returns to set point. We can get a better idea of how the control system responded to the change in oil temperature by looking at the controller's input and output signals on this graph. The input signal to the controller represents the oil temperature. As the graph shows, when the temperature of the oil first began to increase, the controller immediately produced a corrective output signal that reflected the rate of change. This boost of control action stopped the temperature from changing as rapidly as it would have without rate action. As the rate portion of the controller output worked to stabilize the oil temperature, the reset portion of the output worked to return the oil temperature to set point. Soon, the combination of reset and rate control returned the oil temperature to steady state at its original set point. The final output signal also returned to steady state, but at a higher value. The higher output closed the control valve to a new setting to maintain the oil temperature at set point. In this topic, we described how reset control, rate control, and a combination of the two work in an automatic control system. Now let's try some practice questions. Not all control modes can return a controlled variable to set point after a process disturbance. However, reset control is designed to adjust the output of a proportional controller to help eliminate offset and restore original process conditions. Rate control is a control feature that responds to the speed at which a variable deviates from set point. The faster the variable changes, the greater the amount of rate control action. This graph shows the input and output signals for a control system that uses proportional plus reset plus rate, or PID control.